All right. So we are now on chemical bonds. And so whenever you start to think about chemical bonds, you need to be able to identify what type of chemical bond it is, whether or not it's an ionic, a covalent, metallic. There's even hydrogen bonding, but we don't get too much into it until chapter 10, 11. So basically, what you need to know about chemical bonds, this is sort of the definition of a chemical bond, is that it's an attractive force that's holding atoms together in compounds. And it can be described in terms of molecular or atomic. And so the first one that we want to talk about is ionic. And those are where electrons are transferred between atoms and they have an electrostatic force. So the way that I always think about them is they're kind of like sort of almost magnetic. Not necessarily magnetic, but that's the way that I always visualize them. For instance, if you have a sodium ion, like what we talked about in the previous slide, where it loses that outer electron, and so it becomes this positive 1 ion. And then if you look at the periodic table, so I'm going to bring up the periodic table really quick. It's kind of hard to explain this stuff without looking at the periodic table, in my opinion. Okay, so I'm going to kind of number these. These are the representative families, meaning that these are the numbers that they are if you're talking about the tall ones, is what I like to refer to them as. So kind of not looking at this section right here. All right, so like with sodium, we were able to look at this 1 and we were able to see, okay, it has 1 outer electron. So that would mean then, how many outer electrons do you think potassium or K here has? Well, it has 1. Rubidium, the one right underneath potassium, it has 1 outer electron. So what do you think everything in this group has as far as outer electrons? Well, they all have just 2 outer electrons. And if you go over here to group 3A, then they only have 3 outer electrons. And then group 4, and so on. And so that's why I was saying this group right here, this 8th group, they're sort of special. These are the noble gases. And they already obtained that octet rule, so they're good, they're happy. So if you're looking at something like sodium, it's a metal. So metals are always going to lose electrons, meaning that they're going to have positive charges. Because think about it, if you lose electrons, then you lose negatives, okay? Because electrons are negative. So if you lose negatives, then that means that you're going to end up having positive ions. So sodium was positive 1. If we come over here to chlorine, well, how many electrons does it have in its outer electron shell? Well, it has 7, because it's in the 7th group. How many does it want to have to be like a noble gas? It just needs 1 more. It just needs to gain 1 electron. So if it gains a negative, just 1 negative, then it becomes -1. Well, now if you have a positive and a negative, think about magnets. If you have a positive side and a negative side, what happens? Well, they attract. Okay, it's an attraction. So that's what's happening in this ionic bond situation. So let me just ask a couple more questions, because just to kind of make sure that you guys are sort of understanding what I'm saying here. If I said what's the ion for magnesium? Well, if you look, magnesium is in the 2nd group, so it would have a +2 ion. Why? Well, because let me kind of scroll down here for a second. If you draw a Bohr model of it, magnesium is number 12, okay? And basically its mass number is 24. So that means that it has 12 protons and it has 12 neutrons in the nucleus. Remember, these add up to that mass number, that bottom number. Okay, well, how many total electrons can it have in that first shell? Well, it can only have 2. This should be familiar from when you did electron configuration. So then in the second group, that's that row right there. How many total elements are there in that second row? Well, if you count all of them, there's 8. And then if I draw a third energy level, which is this third row right there, okay, how many does it take in order to get to magnesium? Well, you just have sodium and then you have magnesium. So you just have 2 electrons in that outer shell. Well, what group is it in? Well, it's in group 2, so it's 2 outer electrons. But does it want to have 2 outer electrons? No, it wants to get rid of that, and it wants to only have 8 outer electrons, like a noble gas. So it kicks those off. Well, once it kicks those off, it still has 12 protons. But now how many electrons does it have? Well, now it has 2 plus 8, so it only has 10 electrons. So it has plus 2 charge. So that is where I'm getting that number right there. Okay, now I said something a minute ago. I said metals lose electrons. So that means non-metals gain electrons. And that's kind of a symbol. That's a way of writing electrons. You just write this E with a little minus sign after it. Okay, so now if I said, let's say oxygen, what's its ion? So oxygen's over here. Well, if you look back on your periodic table that has sort of the metals separated from the non-metals, you would see that oxygen is a non-metal. And oxygen has how many outer electrons? Well, it has 6. How many does it want to have in order to be like a noble gas? It wants to have 8. It has 6. So it just wants to gain 2 more electrons. So that means if it gains 2 more electrons, then it would have 2 minus as its charge. So let me show you using the Bohr model again. Okay, so I'm going to erase all of this stuff for magnesium, and I'm going to do the same thing for oxygen. Okay, so oxygen is number 8. So that means it has 8 protons. If you look at the bottom number, it's like 15.99. You can't really see that very well. 15.99. So I'm going to say 16. Okay, it's going to round up to 16. So that means that it has 8 neutrons. So if you add those up, you get a total of 16. Well, how many electrons can go in the first energy level? In the first shell, is what I was going to say. 2. Okay, how many elements are in the first row? Hydrogen and helium. So 2. That's all you can have. And then in the second one, golly, my circles are so bad. In the second one, if you count all the way over to oxygen, that's a total of 6. Okay, well, we just said that oxygen was in the 6th column or 6th group, but it wants to be like a noble gas. So if we redraw that circle anyway, and we gain 2 electrons, so instead of having 6 now we have 8 electrons, right? So that means we have 8 protons, or really I should write that as 8 positives. And now if you count how many total electrons, so you have 10 negatives, your overall charge is 2 negative. I know it's kind of a weird way to write it, like instead of writing minus 2, you write 2 negative. That's kind of the way that you write it whenever you're doing the ion. Okay, so now if you have a 2 positive and a 2 negative here, what do you think happens? Well, they attract, and they form what's known as a compound. This is an ionic bond. Whenever you have positives attracting to negatives, you have an ionic bond.